This is SpaceTime Series 27, Episode 114, for broadcast on the 20th of September 2024. Coming up on SpaceTime, did the Dwarf Planet Ceres originate in the Asteroid Belt? A galactic mystery about dark matter and stars finally resolved? And China's Secretive Space Plane returns to Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has raised fresh questions about the origins of the dwarf planet Ceres, the largest body in the main asteroid belt between Mars and Jupiter. The new findings, reported in the Journal of Geophysical Research Planets, challenges earlier observations which suggest that the 960-kilometre wide frozen rocky world may have formed in the outer reaches of the solar system and then migrated inwards to its present orbital position. The dwarf planet Ceres is an unusual inhabitant of the main asteroid belt. It's not only the largest body by far in the belt, but unlike its more simple fellow inhabitants, it's also characterized by an extremely complex and varied geology. Years ago, NASA's Dawn spacecraft discovered widespread ammonium deposits on the surface of Ceres. Now, at the time, some researchers assumed that this frozen ammonium played a role in the formation of the dwarf planet itself. And that's where it got interesting. You see, ammonium is only stable in the outer solar system, where it's a lot colder than it is where the asteroid belt is. And so that would indicate Ceres' origins was far from the asteroid belt. However, new findings from the Consus crater are now raising fresh ideas about Ceres' origin. At 450 million years, Consus crater isn't particularly old by geological standards, but it's one of the oldest surviving crater structures on Ceres. Due to its deep excavation, it gives scientists access to processes that took place in the Ceres interior many billions of years ago. And thus, it becomes a kind of window into the dwarf planet's past. Ceres appears to have been the scene of unique cryovolcanism until fairly recently, and it's probably still occurring there. Now, this is all based on data obtained by NASA's Dawn spacecraft when it studied Ceres between 2015 and 2018. Light-coloured whitish salt deposits can be found in several impact craters on the dwarf planet, and deposits in the Consus crater could indicate ammonium-rich material that had reached the surface from the depths of the dwarf planet due to Ceres volcanism. More precisely, researchers believe that the deposits are the remains of a brine that seeped up to the surface from a liquid layer between the mantle and the crust over many billions of years. Images and measured data from the Consus crater, which scientists have now analysed in far greater detail than ever before, show material that is yellowish in colour. Now, the presence of ammonium, therefore, doesn't necessarily indicate an origin in the outer solar system. In fact, Ceres could well have formed exactly where it's orbiting today. Consus crater is located in Ceres' southern hemisphere. With a diameter of around 64 kilometres, it's not one of the dwarf planet's particularly large impact craters. Images taken by Dawn's scientific camera system show a circumferential crater wall that rises about 4.5 kilometres above the crater floor. This wall has been partially eroded inwards, and it encloses a smaller crater covering an area of about 15 by 11 kilometres that dominates the eastern half of the Consus crater floor. The yellowish bright material is found in isolated speckles exclusively on the edge of the smaller crater and to an area slightly east of it. The new data analysis from the Dawn camera system, as well as the VIR spectroscopic reading, suggests that the yellowish bright material in Consus crater is rich in ammonium. Now, in traces, this compound, which differs from ammonia by an additional hydrogen ion, is almost omnipresent on the surface of Ceres in the form of ammonium-rich minerals. Now, in the past, scientists believed that these minerals could only have formed through contact with ammonium ice in the cold outer edges of the solar system, where frozen ammonium is stable over long periods of time. See, in closer proximity to the heat of the sun, this ammonium evaporates quickly. And all this suggests that Ceres must therefore have formed at the edge of the solar system and only later migrated to its present location. However, the new data shows a connection between ammonium and the salty brine from Ceres' interior. Now, the authors of the new study suggest that the dwarf planet's origin doesn't necessarily have to be in the outer solar system. Ceres could have been native to the asteroid belt after all. The authors are assuming that the components of ammonium were already contained in Ceres' original building blocks. As ammonium doesn't combine with the typical sorts of minerals found in Ceres' mantle, it gradually accumulated in a thick layer of brine that extended between the dwarf planet's mantle and crust. Cryovolcanic activity caused by the ammonium-rich brine caused it to rise towards the surface repeatedly over the course of billions of years. And the ammonium it contained gradually seeped into the large-scale phyllosilicates of Ceres' crust. Phyllosilicates, which are characterized by a layer of crystal structure, are also widespread here on Earth in geology like clay soils. The study's lead author Andreas Nathuis from the Max Planck Institute says the minerals in Ceres' crust possibly absorbed the ammonium over many billions of years, kind of like a sponge. He says there's much to suggest that the concentration of ammonium is greater in deeper layers of the crust than what it is near the surface. The few places on the surface of Ceres where conspicuous patches of the yellowish-bright material can be found outside Connors Crater are also located within deep craters. He says the impact that created the small eastern crater only 250 million years ago is also likely to have exposed material from deep within the dwarf planet, especially ammonium-rich layers in Connors Crater. And the yellowish-bright speckles to the east of the smaller crater could be minerals that were simply ejected debris as a result of that impact. This is SpaceTime. Still to come, a galactic mystery about dark matter and stars finally solved, and China's secretive space plane returns to Earth. All that and more still to come on SpaceTime. Astronomers have overturned a long-standing idea that stars and dark matter interact with each other in inexplicable ways. The old hypothesis emerged to explain a phenomenon that had puzzled astronomers for more than a quarter of a century. That is, that the density of matter in different galaxies appears to be decreasing at the same rate from their centres to their outer edges. And this was perplexing because galaxies are fairly diverse, with many different types, ages, shapes and sizes, and many different populations of stars. So, why would they all have the same density structure? The study's lead author, Kara Dekeen, an Astro-3D researcher from Macquarie University, says this homogeneity suggests that dark matter and stars must somehow compensate for each other in order to produce such regular mass gradients. The trouble is, no one could explain how this would be happening. If dark matter and stars could interact in this way, astronomers would need to change their understanding of how galaxies form and evolve. The trouble is, they couldn't find an alternative reason to explain what they were seeing, that is, until now. Dekeen and colleagues found that the similarity in density might not be due to galaxies themselves, but simply how astronomers are measuring and modelling them. Using the European Southern Observatory's VLT, or Very Large Telescope in Chile, they observed 22 middle-aged galaxies in extraordinary detail, looking back some 4 billion years in the past due to their great distance. A new study reported in the monthly notices of the Royal Astronomical Society says this enabled the team to create more complex models that better captured the diversity of galaxies across the universe. Dekeen says in the past it seems people simply built simple models that had too many simplifications and too many assumptions. She says galaxies are more complicated than that. Dekeen and colleagues then ran their models on the OzStar supercomputer at Swinburne University, using the equivalent of around 8,000 hours of desktop computing time. She says the project used MUSE, the multi-unit spectroscopic explorer, on the VLT to analyse galaxies from the MAGPIE, or Middle Ages Galaxy Properties and Integral Field Spectroscopic Survey.
So there was observations going back to about the 90s, and it showed that the structure of these galaxies was always the same. So obviously when you look at a galaxy and you see the stars, they're not all the same structure in their stars. Like you can have galaxies that have stars that are very centrally clustered in the center of the galaxy, or ones that are more sort of spread out.
Galaxies are a bit different,
All galaxies are a bit different when you look at them, exactly. But then when you looked at the total structure, like the total mass, then they were all the same. So that means that the dark matter must be responding to the stars so that you've got some kind of dark matter distribution and the stars are distributed another way, but together they always make this same structure. Why would the dark matter do that? We didn't really have an explanation for it in the literature, but it was this observation that was sort of popping up again and again.
And so you guys had a closer look at this situation.
We just looked at it in a different way. So previously, you'd look at the total distribution of mass. So looking at the stars and the dark matter all in one without trying to disentangle one from the other. And there were also some modeling assumptions made in there about what could the gravitational field from those components look like. So what we did is we said, okay, let's not assume what the gravitational field looks like. Let's just try and make a model with a bit more freedom in it. So we use a dynamical modeling technique where we actually look at the orbits of the stars that are in the galaxy, and we try and combine these different stellar orbits together to reproduce what we see for the galaxy without imposing anything too strict on what those orbits can actually be.
By looking at the orbits, that lets you know something about the likely mass of the galaxy, is that right?
Exactly. Because if you've got if you've got an orbit that's particularly energetic, or it's very fast, or it's at a particular radius, then that can only happen if you've got a certain mass. So it's the same thing as, if you look at the Earth going around the sun, then you can tell the mass of the sun based on how the Earth is moving around it. So you can tell the mass of a galaxy based on how the stars are moving within it. And when we did the modeling in this way, then the conspiracy just completely broke down. We actually found this huge diversity in how dark matter can be distributed within galaxies. And there was no conspiracy to always have this same structure pop up again and again.
When you do this, is there a need to differentiate between what is baryonic matter in the stars and gas and that, and what is dark matter?
So we model them with different components. So we do say this is the stars and this is the mass that we can attribute to the stars that we can see. And then we have another component that we call the dark matter, but that doesn't necessarily mean that it's an exotic particle. It just means that it's mass that we can't attribute to the stars that we can see. So it could be some other form of mass that's not emitting light for us to know that it's there, or it could be some kind of exotic particle. But I think that's an ongoing mystery for us to solve in the future.
Was it necessary to look at the distribution of the mass to see whether or not the mass of which is attributed to dark matter increases as you get towards the center of the galaxy or towards the edge of the galaxy or anything like that, or that doesn't necessarily need to play a role?
So we did have a model for how the dark matter could be distributed. So there were some very famous simulations run in the 1970s that came up with a distribution for dark matter in galaxies, and that's called the Navarro-Frank-White profile. So we did assume that the dark matter would follow this basic distribution, but that it could have any amount or any, within a certain section of the galaxy, there could be any free fraction of dark matter. So we weren't imposing that it had to kick in at any particular point in the galaxy or anything like that.
And once you looked at those galaxies and did those calculations, the idea of this symmetry between dark matter and galactic mass disappeared.
Completely disappeared. And we found that there's just a huge amount of variation in where the dark matter is located in galaxies. So in some galaxies, we found that you needed a lot of dark matter very close to the center of the galaxy. But for other galaxies, the dark matter, for as far out as we had observations, we couldn't find any evidence for needing dark matter in that galaxy to reproduce our observations. So there was just a huge diversity in that dark matter, but there was no combination, necessary combination between the stars and the dark matter. So there was no universal structure that we were getting from our models that the dark matter was somehow responding to the way that the stars were distributed. Our key takeaway is that galaxies are really, their structure is highly variable. There's no sort of universal galaxy structure.
Were you able to draw any conclusions at all about what role dark matter plays in galactic formation? Because that's one of the big questions. Is dark matter the superstructure around which galaxies are formed?
Yeah, so we still believe that to be the case. So we think that dark matter was the initial mass around which galaxies could form. And so without dark matter providing this gravitational force, then you wouldn't have galaxies forming as they do. So we're not questioning at this point in this study, at least, the role of dark matter in providing that initial gravitational attraction around which galaxies could coalesce. but it's more in the evolution of these galaxies. Like, what role does it play in continuing to shape galaxies as they go from very early objects, like, just after the Big Bang, to the sort of galaxies that we see today?
I know that one of the great mantras of just a few years ago was that small, irregular galaxies and satellite galaxies would have a lot more dark matter in them than baryonic matter, but that was never proven. Were you able to draw any conclusions along those lines at all?
I think what we're seeing again and again, and even with results that are coming from the James Webb Space Telescope, is that we've made in the past a lot of assumptions about, dark matter is going to be prominent at this particular radius of the galaxy. So we wouldn't see it in the center because that's where all the stars and the baryons are. We'd only see it further out. Or even for very, looking further back into the history of the universe, that this type of galaxy would have a lot of dark matter, but that type of galaxy, like, a spiral galaxy, maybe not so much. And then a large elliptical galaxy that would have lots of dark matter. And I think what we're finding now is when we're looking at these, when we've got the observations that can allow us to look at these galaxies in more detail, we're just finding that diversity again and again. There doesn't seem to be a rule that governs how much dark matter is going to be in a galaxy. I think it's coming more down to what particular pathway has that galaxy followed across its lifetime, like has it had any interactions and that kind of thing that can actually create the distribution of matter in it that we see today.
Any special pleading that gravity maybe acts differently at different distances?
So the Mond theory.
You know what I'm getting at.
Yeah, no, I do, yeah. So that's the interesting thing with the models that we ran. We said in the models, like, there's this mass component that we can't see. But again, we're not attributing it to anything in particular. We're not saying this has to be an exotic particle. We're not saying this has to be a modified theory of gravity. And, it could just be stars or gas that we haven't accounted for in our models that aren't really emitting that much light. I think that's still just a big thing that we don't know. But at the moment, we're not able to rule out sort of any of those scenarios. I think it's all still to be found out.
Mond is still up in the air for now.
Yeah, definitely.
This study looked at galaxies out to, about 4 billion light years. Are you looking at expanding on that?
Yeah, so I think it would be awesome to go back further in time, and we've got the instruments now that are allowing us to do that. What's really cool about going further back in the history of the universe is that we've done this kind of study before with local galaxies in our nearby neighborhood, but because they're actually so close up, it's hard to get really far out in terms of the actual galaxy itself. So we're not probing regions that are far out enough to understand what the dark matter is doing. And when you go back further into the universe, the images that you actually, and the data that you collect for these galaxies really allows you to probe further out in the galaxy. So we're getting about twice as far out with these observations compared to local universe studies.
Were you able to draw any conclusions from that, or are you seeing the same sort of pattern?
Well, that was what allowed us to really test this distribution of dark matter, because if you're confined to the very center of the galaxy and you're trying to understand what the dark matter is doing, then it's hard to have enough data to actually draw any firm conclusions. Whereas with this data from the MAGPIE survey, we were pushing so far out to the outer zones of these galaxies that we weren't guessing what the dark matter was doing. We were actually able to measure it.
That's Cara DeKeen, an Astro 3D researcher from Macquarie University. And this is SpaceTime. Still to come, China's Secretive Space Plane returns to Earth, and later in the science report, could lowering high blood pressure be as simple as eating more cruciferous vegetables? All that and more still to come on SpaceTime. China's highly secretive reusable experimental spacecraft has finally returned to Earth following what was a 268-day marathon orbital mission. The highly classified space plane, which is understood to be a rough copy of America's X-37B space shuttle, was launched back on December the 14th aboard a Long March 2F rocket from the Jiuquan Satellite Launch Center in China. Beijing claims the spacecraft's mission was designed to verify reusable technologies and to conduct space scientific experiments, laying the groundwork for future peaceful space operations. Of course, in reality, the truth was somewhat different. The spacecraft appear to be inspecting other spacecraft and occasionally deploying smaller spacecraft towards them for a closer inspection, or possibly to place technology on them. The flight was the third for the reusable experimental spacecraft. Its first test took place back in September 2020, with the spacecraft staying in orbit for just under 2 days. That was followed by a 276-day mission starting in August 2022. Both earlier missions were also launched aboard Long March 2F rockets from Jiuquan. Over the years, there's been a fair bit of confusion as to whether the same type of spacecraft was used on all three missions. That's because several different designs for this vehicle have surfaced. Of course, it wouldn't be the first time a totalitarian government has copied American space technology. The United States pioneered the reusable spaceplane technology with its fleet of space shuttles back in the 1970s. They remained operational for 30 years before finally being retired early in 2011. But not before the Kremlin copied the design and produced the almost identical Buran. The Soviet Union, however, soon discovered that the space shuttle technology, while very advanced, was also very expensive to operate, with each flight costing over $500 million to launch. In recent years, reusable spacecraft designs have advanced somewhat, and vehicles such as Boeing's X-37B, which was originally designed to travel in the cargo bay of the space shuttle, have sparked renewed interest due to their smaller size, reduced operating costs, and simplified operations. And now it appears Beijing is following in Moscow's footsteps, coveting American technology and trying to work out exactly why the United States is using it. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that cruciferous vegetables, including broccoli, cabbage, kale and cauliflower, have been found to lower blood pressure in middle-aged and older adults in comparison to root and squash vegetables. In a randomized controlled crossover trial, researchers from Edith Cowan University found that consuming 4 serves a day of cruciferous vegetables resulted in a significant reduction in blood pressure compared to 4 daily serves of root and squash vegetables, including carrots, potato, sweet potato and pumpkin. The authors say compounds called glucosinolates, which are found almost exclusively in cruciferous vegetables, are appearing to lower blood pressure. Increasing vegetable intake is already widely recommended to reduce heart disease risk, and previous observational studies have shown that cruciferous vegetables like broccoli, cabbage and Brussels sprouts have stronger relationships with lower heart disease risk than other vegetables. However, while these vegetables are consumed globally, cruciferous vegetables typically only make up a small portion of total vegetable intake. The study, reported in the journal BMC Medicine, was conducted over a 6-week period, with participants completing 2-week dietary interventions separated by 2-week washout periods where they followed their normal diet. German scientists have found that larger bumblebees tend to fly faster when foraging, but middle-aged bees fly longer and further. Bees at 1, 2 and 3 weeks of age were attached to a flight mill to fly in circles with the distance, duration and speeds of their flights measured. It turns out their speeds were influenced more by body size than by age, but the flight distances and durations did correlate better with age. A report in the Journal of the Proceedings of the Royal Society Bee found that 1-week-old bees tend to have the shortest flights, typically less than 100 metres. But bees reach their peak distance and durations at 2 weeks of age before declining a little at age 3 weeks. A new study has shown that dogs can remember the names of objects for 2 years after learning them. A report in the journal Biology Letters looked at 5 gifted word-learning dog families. In a previous study, 6 border collies from around the world who knew their toys' names, as reported by their families, were taught the names of 12 new toys and had a higher than random chance of retrieving the correct one for up to 2 months afterwards. Now in this new study, 5 of the dogs were reintroduced to these toys after 2 years and asked to fetch them by name, with most still remembering 60 to 75% of the names. The authors say their findings can't be generalised for other dogs, but similarities or differences in how such gifted dogs and humans form long-term memories of labels might help scientists understand how different abilities evolved in the human brain to help form language. It was once described as the UFO capital of Australia, but now the Wycliffeville Roadhouse is just a ghost town. The settlement, located on the Stuart Highway near Tennant Creek in the Northern Territory's outback, included a bar, a general store and a caravan park. But over the years, this tiny desert oasis began to gain a reputation for UFO sightings, a feature the owners were quick to play upon. There were reports of flashing lights around the sky doing crazy manoeuvres that were hard to explain. The owners set up murals and souvenir stands with postcards, keyrings and books. There was even a ledger of so-called UFO sightings. And there were regular night tours for alien and UFO enthusiasts. But as Tim Mendham from Australian Skeptics reports, eventually the UFO bubble burst.
I've heard of Wycliffe Well, and I actually did. It's on the main highway.
Yeah, the Stuart
that
Highway.
runs through the only highway that runs up through the middle of Northern Territory. It's a pretty isolated area.
Marbles, I believe.
Is it right? Now, I stopped at the Devil's Marbles, but I don't recall Wycliffe Well.
No, neither do I. That you go through Tennant Creek, and then there's the Devil's. Yep. Going south, it's just south of Tennant Creek. Tennant Creek's the big junction for the road to Queensland. I think it's the Barclay Highway. Wycliffe Well, never heard of it.
I've stayed in Tennant Creek twice. On this one trip, I went up there and across. I went to the Devil's Marbles, and so somewhere around that trip, I must have driven straight past Wycliffe Well, which is probably not that difficult. It was a roadhouse with a bit of a caravan park and a little bit of a motel, right? But apparently there was people have seen UFOs in the area. It didn't get much publicity from that point of view. Pretty isolated little roadhouse, but someone covered it in a local newspaper, and bingo, it suddenly became famous around the world. And you had lists of the world's top 10 sites for seeing UFOs, and Wycliffe Well was one of them.
We should point out at this stage that any UFOs could have been high-flying aircraft, because it's right on one of the main flight routes between Asia and south of Australia, where Adelaide's located. It's also on the flight path between Darwin and Alice Springs. And of course, being on the Stuart Highway, you're going to have lots of road trains going along there with their headlights on, their RU lights on, their floodlights, and any atmospheric disturbance will cause the lights from those trucks to appear to be in the sky rather than on the ground.
Absolutely. There's a whole range of reasons why people might be seeing UFOs, or UFOs in quote, in that area. I mean, they probably would have seen them all up and down the area as well. So if it is on a flight path like that, if it is on a major highway, and the highway runs straight up through the area, all those reasons, you should be seeing UFOs all the way. It should be the UFO highway, if anything, but not just one place. But apparently it got a lot of interest. They started putting up little aliens and things all over the place. With this tiny little roadhouse with a caravan park and a motel, he became famous on the world guide list of places you should visit if you want to see UFOs. The fellow who ran the place, he bought it back in the 80s, I think, just before it became famous. He ended up doing tours and going out UFO spotting and all this sort of stuff, and he thought it was fascinating. It's good for business. A little isolated roadhouse in the middle of nowhere. The fellow who followed it also did the same thing.
It reminds me a lot of Area 51 in the United States, where the local roadhouse got on the UFO bandwagon, and also the Roswell in New Mexico for the same reason.
Yeah, most of the actual activity that Roswell was concerned about happened nowhere near Roswell, but the town was the closest town, so they picked up all on the UFO fanaticism. Basically, the whole town is
that's where the radio station and newspaper were based at, and that's where the Air Force Base was, or the Army.
That's where the Air Force Base was, yeah. So, but this was not a town. This was one little roadhouse, and it became very popular. The trouble is it changed hands again. It changed hands to a big petrol company who was only interested in how much petrol they sold. They weren't that, apparently, the owner who then sold it to them said that they didn't seem that interested in following up and promoting the UFOs. So it sort of died out a bit in notoriety, not helped by a flood that raced through the area. It actually took away a lot of the infrastructure of this roadhouse, and so it became a bit of a ruin. So unfortunately, Wycliffe Well is no longer the site to go to if you want to see a ghost house, and I don't know what's happened to the UFOs. Have they gone on to a different roadhouse or what? But the UFO should still be there. Honestly, they don't need the roadhouse to actually appear, but apparently a great site that attracted a lot of people. It's no longer the place to go to.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.